Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics Paper 5-3 for October-November 2024 for questions 1 to 3. Question 1, 30% of the residents of Wimfield own an electric car. 3 residents are chosen at random, but find a probability that either all the 3 own an electric car or none of them owns an electric car. Now, since they gave us this 30% here, it is the P, okay? So the events here are independent of each other. They just get the person, they ask them, do you own a car or no? So they either say yes or no, like that. So, and this one is repeated every now and then, every time they get the person to ask them. So that means this one can either be a geometric or a geometric or a binomial. Okay, now here they are talking about 3 residents. So n is fixed, it is known. That means this is a binomial distribution. So we have p, which is equal to 0.3, and then we have q, which is supposed to be 0.7. Then our n is 3. Now, if they say either 3 own or, so that is a union. So we are going to have probability of x is equal to 3 or 0. So this is the same as saying get the probability of x is equal to 3 and then you add probability of x is equal to 0. Of course, using the binomial expression, we are supposed to have n combination r, where r is the number of times you get the success. So our p here is 0.3, then we shall power it with a 3. And then 0.7 here, it will be powered with a 0. Remember, when you add these powers, they give you the n, okay? Then plus, this one can be 3 combination 0, and then 0.3 power 0, and then 0.7 power 3. So in other words, here we are having only 0.3 power 3. And then here we are having only 0.7 power 3. Because this is a 1, even this one is a 1. Same to this and this one here. So we just have 0.3 cubed and then plus 0.7 cubed. 0.3 cubed, then plus 0.7 cubed. So altogether we get 0.37. 0.37 as our answer. You can even add on a 0. Then here they are saying a random sample of 125 of the residents of Wimfield is selected. Then part B, use a suitable approximation to find the probability that more than 45 of these residents own an electric car. Now, if they are more than 45, that means we are going to have 46, 47, 48, 49, 50, up to 125. When are you going to finish that? So that's why we approximate a binomial to the normal distribution, and the mean of the binomial is given by NP. Remember, when we are using the normal distribution, we need to have the mean and then the standard deviation. So this one is going to be 125 times 0.3, and this one will give us 37.5. Then we also need the standard deviation, which is root of the variance, and variance is given by NPQ. So we shall have the square root of n is 125. Our p, remember, is 0.3, and then the q is 0.7. So what does this give us without the square root? Because I always use exact values. 125 times 0.3 times 0.7. That one gives us 26.25. So I'll just write here root of 26.25. Now, after finding mean and standard deviation, remember, for normal distribution, we use continuous data, but in binomial, we use discrete data. So in order to move from discrete data to the continuous data, because we are approximating the binomial to the normal, then we need to carry out what we call continuity corrections. We are supposed to carry out the bounds of the numbers that are given. For example, here we are given probability of x greater than 45. Okay. So I've always shown you in the videos that we have done before, okay? Every time there is this approximation, I've always shown you where it comes from, why we add a 0.5, why we subtract a 0.5. So if I have 45 here, and then there is 46 here. 45 ends to be so at 45.5, because when you round off 45.5 to the nearest whole number, you get a 46, okay? But then it starts to be so at 44.5. When you round this 44.5 to the nearest whole number, it will give you the 45. So all of the numbers within this region will give us a 45 when we round them. Now we want to get those numbers. Which one is the smallest that we are going to have, that when we round it off, it gives us a value that is greater than 45. Okay, when we round off, remember we are going to use these two. So ask yourself, when you round off this 44.5, do you get a value which is bigger than 45? Of course not. But if I get this one here and I round it off to the nearest whole number, I'll get a 46. So that means approximating the 45 into the continuous data, it will become 45.5. So probability of x greater than 45.5. And I've already said that where there is greater than, you are going to add a 0.5. Where there is greater than or equal, then you subtract a 0.5. And then greater, less than, we shall subtract a 0.5, and then less than or equal, then there you will add a 0.5. So that is that. Here we are going to now standardize. So when we standardize, this will be probability of z greater than, remember z is given as x minus mu divided by the standard deviation. So we shall have 45 here, 0.5, then minus the mean we got as 37.5, then we divide by the standard deviation we got as 26.25. Okay, then I can put this one in the calculator and then we get the answer straight away, like I've always shown you here. Okay, so let's get that. If your statistics, if the calculator is not in the statistics mode, you can press mode, then you press 3 where there is start, then from there you can press SC and then your start comes on the screen. Then from there press shift, then come down here where there is start, there is 1, okay, button 1. Then we shall have this. Now normal distribution is option 5, so I'll press 5, and then 1 here represents probability of z less than a certain value. Okay, and then R is for the one that is for greater than. So probability of z greater than a certain value, that is R. So I'll pick 3 because here we are having greater than. Okay, then I'll put this 45.5 minus 37.5. Okay, then after I'll divide that with the square root of 26.25. Okay, and cross the brackets, and then we shall get 0.05921. 0.05921. And here I've used the calculator. If you want, you can even tell them I've used the calculator. So to 3 significant figures, it can even be written as 0.0592. Okay, so that is that. Question 2. A red fair 6-sided dice has faces labeled 1, 1, 1, 2, 2, 2. A blue fair 6-sided dice has faces labeled 1, 1, 2, 2, 3, 3. Both dice are thrown. The random variable x is the product of the scores on the 2 dice. Draw up the probability distribution table for x. Now to draw the probability distribution table for x, I'll need a possibility diagram. Okay, the possibility diagram, I can put 1, 1, 1, then 2, 2, 2. This is for the red die, and then the other one is going to be 1, 1, then 2, 2, 3, 3. Then I can put these ones in the table like this. So just like that. Now I'm going to put a waiver line here such that I separate these outcomes from all the possibles that we get from here as the scores. So I'm going to put multiplication here. 1 times 1 is 1, 1 times 1 is 1, then here we shall get 2, 2, 3, 3. It's just the product, okay? We get all of these ones here like that, and then 2 times 1 is 2, 2, then here 4, then here 4, then 6, 6, then of course even here 6, 6, 6, 6, then we shall also have 4, 4, 4, 4, then 2, 2, 2, and 2. So that is our possibility diagram. But then the table, which results are we having here? The results we have So let's write and we draw our table. We have x. We only have 2. 1, 2, 3, 4, and then 6. So we have 1, 2, 3, 4, then 6. Then what are their probabilities? Probability of x is equal to x. Then we put this in the table. So now the probability of getting 1, how many ones do we see? They are all here. There are 6 of them. So we shall get 6 out of 36. How do we get the 36? You get, this is 6, the outcomes are 6, then times 6. Okay? You get the 36. Or if you can count manually, 6, 12, 18, 24, 30, 36. Okay? All right. Then next for 2s, how many are they? There are 6 here, then plus 6 here. Those are 12. So we are seeing 12 2s, so 12 out of 36. And then 3s, how many are they? These ones are 6, so we shall have 6 out of 36. How about the 4s? We are seeing 6 of them, so that is 6 out of the 36. How about the 6s? They are also 6 out of 36. Now when you add these, you should be in position to get the answer as 1, because for any probability distribution, the total of the probabilities is always 1. Now you can have 6, 6, 6, and 6, that is 24, plus 12, that gives us 36. So 36 over 36, that one gives us 1. So meaning our answer is correct. Then next, find the expectation. So E of x is actually summation of x, then times the probability of x, which is equal to x. So you get all of those x values, and then you multiply them with their probabilities. So we have 1 times the 6 out of 36. We have 2 times 12 out of 36. We also have 3 times 6 out of 36. We have 4 into 6 out of 36. Then lastly, we have 6, okay, times 6 out of 36. So all of these ones are over 36, okay? So let's get the calculator and then we solve each and everything all at once. So the denominator is the same. I'm just going to deal with the numerators. So we have 6, then plus 24, then plus 18, then plus 24, and then plus 36. Okay, I've multiplied the numerators. So that is 108. So we have 108 here as the numerator, then over 36. And of course, when you divide this one, it gives us a 3. So mean is therefore equal to 3. As simple as that. Question 3 is coming from normal distribution. In Molimba, the heights in centimeters of adult males are normally distributed with mean 176 centimeters and standard deviation 4.8 centimeters. Part A, find the probability that a randomly chosen adult male in Molimba has a height greater than 170. Probability of, let's say, x greater than this 170. We are supposed to standardize this, so it will be probability of z, then greater than, remember z is equal to x minus mu over the standard deviation. So this one is going to be 170 minus 176, then we divide by the 4.8, okay? And then when we simplify this, what do we get? So we have 170 minus 176, then we divide by 4.8. Then this one gives us negative 5 over 4. So we shall have probability of z, which is greater than negative 5 over 4. Okay, if I can do a bell-shaped curve here, negative is of course on the left side of the mean, okay, and they want greater than, so it is this way here. But this one is the same as this one, the one less than the positive one, okay? These two are equal, okay? Those two are equal. So that means when you go to your table and then you read this one for 1.25, it is the same you're going to get here. So using the calculator, I can get the answer straight away, okay? Now we have our start has to be there. So mod, then 3, then we press SC, then now shift, then 1, then you go to 5, and then this is greater than, so we pick arrow, which is 3, and then I'm going to put negative 5 out of the 4, okay? Then this one gives us 0.89435, okay? 0.89435. which I can write to three significant figures as 0.894. Okay, three significant figures. But just like I've said, this one here is the same as the probability for z less than, this one is 1.25. So I can go to the normal distribution table, and then I get this answer. Now here I use the R for greater than. How about when I use P, which is for less than? Let's check. Now here I will go to, again, shift, then 1, then distribution is 5. Now for less than, it is a P. Okay, so I'll pick 1. Then I'll just put that positive 1.25. Do you see that we get the same answer? Okay, now let's go to the normal distribution table, and we also see whether we get the same answer here. So this is our normal distribution table. 1.2 is here, then 5 is here. So I coincide these two here, so they meet here. It is 0.8944. 0.8944, because this one, it gives you only 4 decimal places. Let's go back and see what we got. This one is 0.8944. We got 0.8944. Do you see that when you round this one off, you also get 8944 to 4 decimal places? So whether you use the calculator or the table, you get the answers. All right. Then here they are saying 60% of the adult males in Molimba have a height between 170 and k centimeters, where k is greater than 170. Part B, find the value of k giving your answer correct to 1 decimal place. Now, we are going to have an interval here, probability of now 170 less than that x less than the k. So we are supposed to find that k. So by standardizing, I can have probability of this is 170 minus 176 over, of course, the standard deviation is 4.8. Okay, then less than, this will be z, then less than k minus 176 out of 4.8. Okay, so this one is actual probability of -5/4. We have just done it up there. Then less than z, then less than, let's say this is z2. I need to find this z2 to get the k value. So if I have these two, it is going to be, if you are having the z value here, the bell-shaped curve here. So this is -5/4. Okay, and then I have a z value here. I don't know whether it is positive or negative, z2. So I need the probability in between them. So automatically this one is going to be, get probability of z less than the z2, then subtract this one here. You will get what is in the middle. Okay, so we shall have probability of z less than z2. Okay, then minus the probability of z, minus the probability of z, then less than that -5/4. Okay, but now this whole probability is actually equal to 0.6. Okay, it was given here, this whole probability is equal to 0.6. Now we have probability of z less than z2, then minus, do you know that for this one here, we got it up there as for less than, what we got here was for greater than -5/4. Now for the less than, I will just say 1 minus the 1 for z less than. Okay, even from the normal table, they always give the one for the negative. Okay, let me show you. They always state the one for the negative here. Phi of negative z is 1 minus phi of z. What does it mean? If we have a sketch here, and this is the negative z value, then the less than, because this one is for the less than, this one here is the same as getting the probability greater than that same z value, but on the positive side. It's the same as this one. But now to get this, you'll get the total, which is 1, then minus this one, which is for the less than, z less than z1 or z2, whatever. So you see, that is that. So here I can put 1, then minus that 0 point. Actually, we even got it here, the one of the positive here as 0.9. Let me just write this one here straight away such that we don't waste time. So this one here, which was 0.8944 from the table, okay? So I say 1 minus 0.8944, okay? Then this one is equal to 0.6. Now making this one the subject of the formula, probability of Z less than Z2 is now going to be, let us first simplify this, then we take it this other side. 1 minus 0.8944. We get that, okay? And it is going to be a negative since we are having a negative outside here. So when it crosses, then it will add up, okay? Now I'll just say plus 0.6. That is 0.7056. 0.7056. That is what I will have there. Now, I will do another simple sketch here, and I see whether the Z value is supposed to be positive. So the Z value here is supposed to be the phi inverse of this 0.7056. So which Z value gives us this probability? That is what we want to find out. So if I can put the Z2 here, and I can also make another sketch. I told you you do two sketches, okay? I can put this one on the right, it is positive, then the one on the left is negative. We are looking at less than, so we look at the left side and also the left side here. Then you ask yourself, which of these two can correspond to 0.7056? Of course, it cannot be this one because it is less than 0.5. And know that half of this bell-shaped curve is 0.5. So this one has to be less than that 0.5. You see that? So that means we are taking this one here. So that Z2 is going to be a positive value. You see that? Now let's go to the table and then we find out what we are supposed to get from there. So from our normal table, we are supposed to look for 0.7056. We are supposed to look through this body here. So 0.7056. Now you can see that here there is 7054. This is 7088. It's already big. Okay, so I'll pick this one here, 0.5, and then the 4. So I'll first put it here, 0.54. Now, what did they add on the 0.7056 to get 0.7056? Automatically, that has to be a 2. 0.7056, you subtract this smaller one, 0.7054, you'll get a 2 here. So you write this 2 from the end. Okay, now you go this side and look for the 2. The 2 is not there, but I have seen 3, which is nearest to 2. Then I'll pick this value here, which is a 1. So that means my Z value is 0.541. So Z value here is 0.541. Now, I'll get this value here. Remember, this expression is for the Z2 here, which we have found. So I'll say K minus 176 out of 4.8 is equal to the 0.541. Then I can cross multiply. This means that K can be equal to 0.541 times 4.8. Then we add, because this one has already gone this way, then you put this one this other side. So we shall add on the 176. So putting this in the calculator and we simplify this, what will be the value of K? 0.541 times 4.8, then plus 176. This one gives us 178.5968, but I'll write to maybe one decimal place, 178.6. All to 3 significant figures, you can write 179, okay? 178.6. okay, to one decimal place. So that has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next video.